Welcome everyone. Today we present HAAS, Heuristic Algorithmic Analysis System. HAAS is specifically designed to enhance programming education. It's a logic-driven programming language which is based on Prolog and structured approach to coding a concept. The name HAAS also comes from our initials of our team members, which is a fun fact. And yeah, HAAS combines Prolog's pattern matching algorithm with computing concepts to provide an educating programming language. And yeah, so we have an intuitive language for education. These are the project objectives of HAAS, which is an intuitive language for education and supports multiple paradigms like logic programming and also imperative programming. And we have a build foundation for algorithmic problem solving, which focuses on algorithmic thinking to equip learners with essential skills for tackling programming challenges. And coming to the implementation strategy overview, our base technology is a stepwise Prolog, chosen for its strengths in logic programming and natural language processing. The processing pipeline for HAAS flows from source code to tokens to abstract syntax trees, and finally evaluation. We use Prolog's definite clause grammar rules for parsing and interpreting educational programming syntaxes. Uh, and scripts and command execution are managed with the shell scripts, and the system is compatible with Mac OS, Linux, and also Windows. The primary aim is to analyze and teach programming, providing insights and heuristics for learners and instructors. The next slide will be taken over by Anadi.
Hi everyone, my name is Anadi. I'll be discussing the project structure and the capabilities. So the project has a compiler components which is for lexical analysis and syntax analysis, and then we have runtime, which is HAAS runner and the parser, and then we have the sample data directory. In this we have few examples of the what sort of syntax is needed for this. For example, for arithmetic, for if else, I'll show that later. And then we have the execution script to run any HAAS script. We just gotta run HAAS and give our the file folder name. And after that, I'll be discussing next slide. Sure. So the HAAS capabilities, we have various type of data types such as integers, floats, booleans, and strings. And then we have operators, which includes addition, subtraction, multiplication, division. We do have relational operators as well, which is greater than, less than, equal to, not equal to, greater than, equal to, less than, equal to. And then we have control flow mechanism, for example, if then statement, if else statements, while loops, ternary expressions, etc. Next slide. Sure. Um, so the grammar and DCG overview, we use definite clause grammar to define HAAS grammar. DCG and Prolog allow us to represent formal grammar rules and making parsing easier and more reliable. For example, a DCG rule in assignment would have a statement which assign ID to expression, and then we can separate out using tokenization the ID, the assignment expression, and the semicolon. The declarative nature of DCG supports bidirectional parsing and efficient pattern matching. Next slide. So lexical analysis, this contains the tokenizer, recognizes keywords, operators, identifiers, and literals. It also handles comments and white spaces, ensuring clean and token streams for parsing. The robust lexical analysis is fundamental for building the reliable program language. Uh, Harsha, can we show the example now? So we have this arithmetic example where we are assigning a, which is equal to 10 plus 5 into 2. And as you can see, the tokenizer works on its way. It separates out the ID a, which assigns number 10 plus operator plus and the number 5 into number 2. Then we have semicolon. And similarly for the B session, we have assignment and then we have the parenthesis. Like this, we are separating out each character in the code. So I think that's it from my side. Over to Simran.
Hello everyone. My name is Simran, and today I'll be talking about syntax analysis and AST. So, what exactly happens after tokenization in HAAS? So, after the tokenizer breaks the source code into tokens like IDA, assign, num10, op, plus, etc. These tokens are passed on to the parser. The parser, implemented using Prolog's DCGs, organizes the tokens according to the grammar rules that we defined in our parser file. This process builds an abstract syntax tree, which is a hierarchical data structure that represents the logical structure of our program. For example, if we move to the code, Harshvardhan, if you could just navigate to that part, and we can see the arithmetic example, and that becomes the AST node assign A, add num10, and whatever has been highlighted. So this tree structure omits the unnecessary syntax like parentheses and semicolons and focuses only on the core computation and relationships between the operations. The syntax analysis or parsing does two crucial things, which is enforcing the grammatical structure and ensuring the correct operator precedence. Like in 10 plus 5 multiplied by 2, the multiplication binds tighter than the addition so that the AST correctly nests the multiplication of num5, num2 inside addition. This is handled in our DCG rules by separating terms, factors, and expressions, and by the recursive structure of the grammar. Moving on to the next slide, we have control flow mechanisms. Now, how does HAAS handle the control flow? Control flow that determines the order in which statements are executed in our program. HAAS supports several control flow constructs, each with a clear representation in the AST. If then else statements, which allows the program to make decisions based on conditions. If we move to the code, in our code, which is parsed as if condition, then branch else branch, we can see that the example of if x is greater than 5, we see that it prints x is greater than 5, otherwise it will print x is less than or equal to 5. So the parser matches the if, then, else, and end keywords and builds the corresponding AST node. Then we have our ternary expressions, which provide a shorthand for simple conditional assignments or expressions. And the parser identifies the ternary pattern and creates the appropriate AST node. Moving on to while loops, which enables repeated execution of a block as long as a condition holds. The parser recognizes the while, do, and end keywords and builds a loop node in the AST. And we also support input-output operations, including the print statements and file output. To perform the input-output in HAAS, we use the print statement, which displays values to the console by the default. For file output, we added a feature where we can set an output file using the set command in our Prolog session before running the HAAS program. And after this, any print statement in our HAAS code will write its output both to the console and to the specified file. That's all. Over to you, Adishesh.
Yeah. Hello everyone, my name is Adishesh and I'm going to be talking about execution methods in HAAS. So HAAS can be run in two main ways, for file execution and other is the REPL mode. For file execution, we use the shell script run underscore HAAS.sh followed by the path to the sample file to run a program file. And then REPL mode, what REPL mode is, it creates an interactive session for a better learning experience of the HAAS language. So it can be run by you just running the shell script. So we can read the HAAS code into Prolog using read file to string, tokenize it, parse it into an AST, and then evaluate it. File output is supported. Set the output file in Prolog to capture the results. Can you go to the next slide? Runtime execution overview. So here we use a file called haasrunner.pl. So what this file does is it acts as a main driver for HAAS language. So this file serves as the main entry point for running HAAS programs supporting both file execution and interactive REPL. What REPL stands for is read, evaluation, print, and loop mode. It also handles tokenization, parsing, and evaluation. It reads HAAS source code, tokenizes and parses it into an abstract syntax tree, AST, and then evaluates the code, displaying results or errors as needed. It also includes interactive teaching mode, as I said earlier, which is a built-in tutorial system which guides users through HAAS language basics like algorithms, arithmetic, logic, and more with more hands-on examples. Can you go to the next slide? HAAS teach mode. This is nothing but the REPL mode. So HAAS features a special teach command in the REPL for guided tutorials. These tutorials offer interactive step-by-step learning with environment inspection and hands-on examples. This mode is designed to make learning program concepts engaging and accessible. We'll show you a short demo later on.
Okay, moving on to the next slide, which is development challenges and solutions. At first, we have keyword recognition, in which the explicit BCG rules enhance recognition of keywords versus identifiers. Next is expression precedence, structured grammar with precedence levels, which aids in handling the expressions correctly. That is something that we did face a problem with. Then file output integration, in which there is dynamic predicates and stream handling facilitated by effective file output integration. And lastly, loop and nesting support, in which there's a recursive environment evaluation supporting the complex loops and nesting structures. Moving on to the next one.
For future scope, we need to enhance some logic and programming constructs to make it more supportive to the logic programming. And then we gonna improve the grammar for the error messages for better learning and better understanding the error in your code. We also gotta add more functionalities to the teaching mode, which is the REPL. And we need to introduce type interference and a web interface for HAAS REPL. That's it from us. Now, Harsha, show the demo.
Yeah, I'll just take you guys quickly through a demo. To give a quick summary, the tokenizer is a file that breaks the input into strings and classifies into tokens, and the parser is a file which makes abstract syntax read from the tokens, and evaluation is the file which traverses the AST and maintains the environment and the variable bindings and evaluates expressions and handles the output. The environment is represented as a list of pairs, variable name and value pairs, that gets updated as a variables as variables are assigned to the values. And I'll just run this demo code, which consists of all the basic operations like Boolean operations, arithmetic operations, logical operations, and also looping. So this is the sample run of. So yeah, this is a sample run of this demo file that we have. As we can see, every output lists out the tokens, the AST, and also the original output of the code. So the tokens listing of the tokens and AST helps the student to learn more about how the language passes the code. And yeah, so that ends the demo for now. Thank you.
Can you just show the REPL demo one?
Yes, sure. So yeah, Adishesh is going to take over and show you guys the REPL demo that we have.
So we're just running the shell script as I said earlier. So it shows an interface tutorial. Like you have to just type teach. So it gives an interface. Here we can select anything like basic syntax and assignment. So let's just select one. So here it gives prompts. So if we just type this prompts, we'll get to know what the results are. So this is for a better learning experience for new users and get to know the HAAS language easily and for easy understanding. Can you just assign a
So
string?
after every learning module, the cycle gets set back to the menu, and you can run a different module to learn a different language. Yeah, it says press enter to return to menu, and then you can choose a different topic to start with.
Okay.
Yeah.
Thank you guys for the presentation. Thank you all for your attention. For more any information, check our GitHub and documentation. Thank you for being a great team.
Yeah. Thank you, everyone.
Thank you, everyone.